Good afternoon. My name is Dr. Michael Harré. I am a researcher with the Modelling and Simulations Group at the University of Sydney. And today I'll be talking about social networks for hybrid artificial intelligence human interactions. I'll be giving an overview of some of the recent progress that's been made in this area and some of the future directions. I'll cover a number of topics in this talk. First of all, I'll start by motivating a theory of mind for both social networks for biological agents as well as artificial agents. I'll talk about collective intelligence and then the social brain hypothesis, stochastic block model as a way of talking about social networks, and then cognition and an artificial theory of mind and some of the consequences and prospects. So first of all, to motivate the theory of mind, some recent ideas have been emerging around the social, neurological aspects of the way in which humans developed and what consequences that might have for the way in which we want artificial intelligence to behave in the future. And so one of the reasons that we might want to have social artificial intelligences is because the way in which we learn relies heavily on social interactions. And so with that in mind, we have a number of different ways in which we can learn. So social learning categories include things like enhancement, where an agent observes a model that focuses on particular objects or locations and consequently adopt the same focus. So a human looks at an object and another human follows that object. Observational conditioning, where there is a demonstration that exposes the learner to a new relationship between two stimuli that hadn't been previously recognized by the learner. And that causes the learner to form an association between the two objects. Affordance learning is where an agent learns the characteristics of an object and through observing those characteristics is able to learn the new aspects of it which it can use in its own use of that object. And copying, both imitation and emulation, where the observer copies the actions of the demonstrator, or the observer copies the results of the demonstrator's behavior within an environment. And so in this way, this is one way in which human agents, are able to learn in a natural environment. And perhaps this might help us in some way understand how to better engage with learning more realistic tasks with artificial intelligence. Of course, one of the other things that we can get from more sort of collaborative perspective with artificial intelligence is this idea of collective intelligence. So collections of humans, of course, when they interact with one another, are able to do more collectively than they are able to do individually. And so this is the essential puzzle of collective intelligence. It is whether the collective judgment from a group of people can outperform whether the outcomes of an individual reasoning by themselves. And so, of course, one of the things that has made us so successful is the fact that when we do interact with one another, we are able to achieve more successful outcomes. And this first came about as an idea with the collective intelligence of wisdom of crowds, where individuals can make an estimate of, say, for example, at a fair, you would have individuals that might estimate the weight of a cow or a pig or something like that, and that collectively the average estimate was better than any individual's estimate. So this was the wisdom of the crowds. But can we do better than that? And so there is significant work at the moment going on around exactly what that would look like. And so there are ways in which consensus decision-making and combined decision-making are being used to understand the way in which we interact with one another in order to make better decisions. In order to do so, we need some way of quantifying what collective intelligence means in human groups, first and foremost, in order to understand perhaps how that might be extended to artificial intelligences. One of the interesting things that came out of this particular article in the proceedings of the National Academy of Sciences is both that the diversity of the group improved the performance of the group as measured by the ratio of males to females in the group, and that this was mediated by social perceptiveness. So that is the degree to which people are able to perceive social interactions, be able to use and adapt to those. And so that social perceptiveness is something we're going to return to later with theory of mind. Within collective intelligence, we also have the origins of human cumulative culture. So historically, humans have interacted with one another in order to be successful from the age of hunter-gatherer societies all the way through to our current larger communities in cities and countries and city-states. And so a great deal of work has gone into gathering information, data on how groups were formed, what size they were, what roles they played in hunter-gatherer societies, and all sorts of rich and diverse ways in which we can understand what it was like and how we formed groups early on in our evolutionary history and social history. But we want to be clear about what it is that we can actually do. So obviously, there are some things that we want to be able to achieve that require permanence of structure. And certainly some collective intelligence solutions that come about. For example, we see in ants bridges versus human bridges, we want, in some sets of circumstances, things that are permanent, engineered, and that can last for extended periods of time. At other times, we want adaptive structures, such as the sorts of things that we get as an analogy to the same bridges that we see in ants that try and do the same sort, that have bridges themselves. But we want something which might be more adaptive and plastic under a certain set of circumstances. And so in order to understand first and foremost how we became so successful as a culturally and socially interacting species, Robin Dunbar looked at the way in which our brain was structured as a species and compared it to other primates, and looked at the group sizes, social group sizes of the individual species. And so one of the striking findings was that the area of the cortical region of primate brains was strongly correlated with social group sizes. So there is a correlation, a correspondence between brain function or brain capacity, cognitive capacity, and the size of our social groups, and that this is not some breakaway event in human evolutionary history. We belong to a continuum of brain sizes and group sizes. And we can see that those primates with smaller cortical regions have smaller sizes, and there is a smooth continuum up to Homo sapiens, where we have the largest cortical regions and also the largest group sizes. So we belong to a continuum. We aren't special in this sense. We are simply a continuation of an evolutionary history. And to get to that large social group structure, we need to understand how the individual fits into that. And so an egocentric network is the first step that takes cognitive capacity and builds a local group structure for every individual. So every individual that's in a social network has an egocentric network, the network of relationships that have the single agent at the middle of it. But every single agent in the system has an egocentric network to which they belong as the center. What happens in a social network is that then all of the egocentric networks are essentially combined together to make the collective whole. What this tells us is that the structure of the egocentric network dictates what the size of the whole network is. And so this gives us a way in which we can see the relationship between the whole social structure and the individual cognitive function being mediated by the egocentric network that the individual agent is able to construct. And now we can look towards what is actually involved in these social networks, and we can compare and contrast different network structures to see which is probably a better fit to the data. So here we were looking to understand the way in which hierarchical networks formed and the statistics of hierarchical networks and how they might be compared with egalitarian, free-forming random networks. And what we found was that egalitarian, free-forming networks described using Harré, layered Harré networks were a better fit to what we saw in the paleo record of hunter-gatherer societies than were dominance hierarchies, the sorts of things that we see with what we see in some of the other primates, where there is a strong hierarchy of alpha, beta individuals within the group hierarchy, and that is what dominates the society. In order to understand how that actually works, well, we have this idea that the social network topology is the thing which dictates how effective the social group is at collectively coming to solve problems, collective cognition in a social sense. And so here we're talking about the re-regularization of ordered networks and random networks. And what people have found is that there is a relationship between disordered networks and computation in the Harré framework, the framework that we used in order to understand the layers of human society, human hunter-gatherer societies. And what does this look like? Here we're talking about a model in which for socially, cognitively mediated social networks, we are talking about this idea of a stochastic block model. In order to understand that, what we have is smaller blocks of connected agents in a social structure that then aggregate together to form the next layer up of social structures. So on the left-hand side here, we have the adjacency matrix of the network. On the right-hand side, we have the equivalent of the actual social network itself as a network. And if we do this in repeated layers, we will get these layers of networks that form that are all at each individual layer based on an Harré network, but as they form layers, they become scale invariant in their structure. Each structure is a repetition, in some sense, of the one immediately below it. And there are multiple versions of this. So other people have looked at the stochastic block model and seen how that block model, how the different versions of that block model might actually look. And so the two that we compared and contrasted in our work are figure A and D in this, where the hunter-gatherer egalitarian society, which has been a long-standing hypothesis in social anthropology, was compared using the data other people had gathered with the hierarchical model plot D in this diagram. And so we found that it was the egalitarian society which was far more suited to the data that we'd seen. Now, of course, it's not immediately apparent that a stochastic block model should in fact be the appropriate framework in order to think about collective intelligence in society. In order to find some analogous evidence, in order to draw a parallel here with other forms of computation, I want to draw your attention to what has been done in understanding the connectome in the human brain. And the human brain obviously can be seen as a computational device. And as a computational device, the connectome is related to the stochastic block model in a quite nice and appropriate way. By analogy, one can imagine that rather than talking about computational regions of the brains and the connectivity between those regions of the brains, what we might think about in terms of computation are different groups within society and how they communicate with each other as a way of understanding computation within society. And so if block models are appropriate for both of those, there is at least the possibility that computational basis of using stochastic block models might actually be the way to try and understand these things. And so there's work done on exactly how that actually looks out. So combination of clustering and disbursement across the human thinking. And so how does this look in practice when we come to look at the way in which networks actually form? Well, so this was part of a piece of work that was published last year within my group, where we are trying to understand the way in which individuals are able to form dyadic relationships between individuals that are the initial formation of what it is to have an egocentric network. So how are we thinking about things in order to form relationships, stable long-term relationships with other people? Well, one way in which we do it is through the idea of metacognition. Individuals think about themselves, individuals think about other people, and in thinking about thinking, what we're engaged in is metacognition. So on the left-hand side, we have agent one thinking about agent two. On the right-hand side, we have agent one thinking about themselves, so reflecting on their own cognition. So thinking about yourself and thinking about other people are both types of metacognition. In the game theory of mind that was introduced by Yoshida, Dolan, and Friston, what they introduced was the idea that you could think about someone else thinking about the way that you're thinking. And this was strategic hierarchies that they were most curious about. Now, of course, to expand this beyond what Yoshida and colleagues actually said, you can also include not just what I am thinking about someone else thinking about me, but I am thinking about myself, thinking about other people. And both of those are part of metacognition, but they have two different relationships that are being envisioned. And of course, what happens in game theory, and this is where this work originally came from, is that the relationships between thinking about other people become tightly formed as a dyadic relationship when we start thinking about me, thinking about you, thinking about me. When that becomes a correspondence, it looks like the correspondences that we use in economic game theory. But of course, this is talking about dyadic relationships far more generally, talking about the ways in which people interact with one another and stabilize their relationship. And so where does all this fit in with artificial intelligence? Well, theory of mind can now be thought of as in a primitive way in terms of inverse reinforcement learning. So reinforcement learning in which individual agents, artificial intelligences, are constructing models of other agents in order to better respond to the environment in which they're working, their social environment in this case. So rather than reinforcing on the basis of the environment or other people's behavior, actually building an internal representation of what is going on inside of that other agent in terms of goals and beliefs and preferences. And so this was published earlier this year by myself and my PhD student. And so, of course, now, what are some of the consequences of theory of mind-based social interactions in artificial intelligence? Well, one of the things that other groups have been working on has been this idea that we can build up different cognitive models, and we can look at decision theory, the way it's been understood and developed over the last 100 years or so, and we can start now looking at those in terms of explicit expressions of the way in which we constrain our decision making based on particular model structures. And we can now extend that not just to individuals making decisions against nature, against a non-reactive environment, but now we can start thinking about building these models in terms of having a representation of not just our own decision making, but the decision making of other agents, and using that to extend our understanding of these things. But of course, theory of mind is only one aspect of the way in which we think and adapt and learn within these environments. So when we're talking about social cognition, there is actually a huge range of different functions that we're trying to capture. So for example, the recent model Cicero has a complex and integrative architecture, but we don't get theory of mind for free just by scaling up large networks. And so the AI scaling hypothesis is probably not correct. But the human brain is modular with lots of interacting functions. And these are the things that we're going to have to start taking seriously when it comes to trying to integrate functionality. And so we find that, and so the modular structure of human cognitive abilities has to be taken into account when we start thinking about these things more carefully in each of these more extended environments. And of course, the social network topology is critical in understanding how our collective cognition, collective intelligence actually works within our social groups. And so one way in which we can think about that is in terms of a very sort of a naive, a sort of simplistic way in which things are being expressed in the popular press at the moment. And so here we have the idea that we are going along at some fairly sort of base level of advancing the complexity of artificial intelligence. We're going to get to a tipping point, though, so the argument goes, where we're going to end up in a very negative state. And so the sort of state that Will Smith in the movie I, Robot found himself. And so in that catastrophic outcome, we find ourselves in a dystopic future. But of course, there are alternatives. And so in Bicentennial Man, Robin Williams plays a robot in which there is a positive outcome where we start to come to legally understand agency for robots, many hundreds and hundreds of years into the future, and how that actually might evolve in a sort of societal way as we introduce laws progressively, as become acclimatized to having robots and artificial intelligence around us behaving more and more like people. We don't know which way this is going to go. This is obviously an enormously rich and heavily debated area at the moment. But we need to keep in mind that there are not just two, but there are many other alternatives. But these are the two that tend to be debated most strongly at the moment. We need to keep in mind there are many different ways to see this. And so in these ways, we may think of these two alternatives being in terms of the way in which the collective intelligence of artificial intelligences brought into social structures within our society, different structures will give rise to different outcomes. And so it is up to us, perhaps, to produce artificial intelligences that have a particular structure within society, interact with us in particular ways, that give rise to alternative outcomes that we want to have, as opposed to obviously outcomes that we don't want to have. How do we actually go about doing that? And that's a far more interesting question than simply the world's going to end in one direction or the other. And of course, if we get it right, we end up in a positive utopia. And of course, we get it wrong. Potentially, we get into the dystopia that people are worried about, rightfully so. But of course, we aren't at the level of psychological theory of mind for AI yet. So connections between neural development, psychology, we simply don't understand these well enough yet to have a true, deep understanding of the AI of psychology. And so, written in 2019, an article by Shivlin and Helena talks specifically about how we use psychological terms in artificial intelligence, and we should be careful of using these terms. And of course, we get to 2023 with ChatGPT, GPT-4, and we find that we are using what are rich psychological terms freely to try and describe the way in which these agents are behaving, the way they're communicating with us. And we need to be cautious of exactly how that actually looks in practice. And of course, this was the 3 laws of robotics first introduced by in science fiction by Isaac Asimov. And of course, this is how he believed that we should interact with other agents in a rational way. But of course, perhaps the way in which we should approach it is by engineering social constraints into artificial intelligence. How do they interact with us socially? What structural roles do they play in our social interactions to find better outcomes for humanity? And how does that actually look in practice? Well, we need to start thinking about how they can understand us better in order to behave within our social constraints in such a way that benefits all of us. Thank you very much for listening.